The reality of computing today for most people is a variety of wonderful and amazing tools, which frequently don't work well together.
How do I get stuff to print on this printer? Where can I find the sources for this operating system?
Bogus. Why didn't you use
What's
a
the
bubble
best way to
sort
copy
here?
a directory and its contents?
Which C compiler do you use?
How many megs of memory does this thing have anyway?
Do you know anything
What does
about the
file not
synchronization
found
routines
mean?
in this database program?
What mail address should
I
I
changed
give
my
people who want
password.
to send me electronic mail?
Doesn't this thing come with a manual?
The solution to this problem would seem to lie in a computing system which could offer the benefits of all these diverse and useful systems within a common environment.
Carnegie Mellon has a long history of computing and computer science research, almost 30 years worth. In the early 80s, it became clear to a number of us that we should consider whether that world of networks and workstations, which we had been using in our research world, could be transferred and used throughout a university. In the fall of 1981, President Syart set up the Task Force for the Future of Computing, of which I was the chairman. With faculty members and students from all over campus, we met to consider whether in fact we should produce such a system at Carnegie, and whether in particular Carnegie was really ready to engage in such an experiment. Out of that came a joint endeavor between Carnegie Mellon and IBM to establish on campus the Information Technology Center, which was to produce just such a system. This was to be an integrated network with a uniform file system using advanced capability workstations. It was to be used not only for research, but for education, especially undergraduate education, and into the dormitories. The Andrew system, the first fruit of this endeavor, has been operational since early 1986 and is now being used by all departments across the campus.
Now, the general technical theme of Andrew as a system was to try to combine the best features of personal computing and time sharing. It was a premise of the system that everyone who could type at Carnegie Mellon would have a personal computer or a workstation. Given that people would have lots of computation, the question is how would they communicate? The key to this, we felt, was having a common file system. In fact, at that time at Carnegie Mellon, lots of people were using time-sharing systems, but they, in fact, were all balkanized into little areas and were trying to intercommunicate among themselves. We wanted to sweep all that away and have one giant file system that the entire campus could use so that no matter what computer you walked up to, you didn't have to worry where your files were or where anybody else's were. That's called the Andrew file system, and that's a piece which has been in place for a few years now and has thousands of users. The second important area that we concentrated on was the creation of a user interface toolkit. Given these workstations with powerful bitmap displays, we needed ways in which programmers could create interactive applications which would exploit that display. We built the Andrew toolkit first on our homegrown window manager and then later on the X11 window manager, which runs on all the popular workstations. It allows programmers to not only create interactive applications, but to combine their applications with other programmers who haven't necessarily been in the same room designing it. On top of the toolkit and the file system, we have something called the Andrew Messages system. And it really exploits the power of both of these to produce what must be the world's best electronic mail system. It provides multimedia mail. People can send mail back and forth to each other on the campus that contains pictures and text and drawings and all sorts of things. It provides on and off campus mail, and it provides access to something like 1,500 different bulletin boards, including things like the Dow Jones Information Service. Another part of the system that's important to understand is that we built the whole thing on Unix so that in fact Andrew can run on any system which runs a Berkeley Unix system. This has allowed us to run it on 3 different kinds of computers so far. For the most part at Carnegie Mellon we have IBM RT PCs. We also have a large number of Suns and Microvaxes from Digital Equipment. The system runs more or less interchangeably on all these systems and can be ported to others easily.
The Andrew file system insulates the user from many of the problems in mainframe usage while still allowing transparent access to files throughout the system. In addition, the cell architecture used in the Andrew file system permits individual departments to retain control over the administration of their computing facilities without unnecessarily restricting the flow of information across departmental boundaries.
The Andrew file system is primarily a communications medium. It must be fast, obviously. It must be reliable, since it's used by many people for their work. And it must support many, many users, since we expect to have 5,000 students using the system at once, in the best of cases at least. Our system is built on top of the Unix operating system, primarily because the Unix operating system is supported by many vendors, and we did not want to tie ourselves into any one vendor early in our project.
The Andrew file system is comprised of two types of machines, file servers and workstations. The file servers are the primary repository of data, and the workstations are the primary users of that data. When a user accesses a file, that file is transferred from the file server to the local disk of that user's workstation. All further accesses to that file occur without having to communicate with the file server. This process occurs completely transparently to the user. The user does not have to specify that the file be brought to his local disk or indicate where the file should be stored on the local disk. The file system takes responsibility for making sure the appropriate set of files are on the user's workstation. This results in greatly reduced network costs, since most of the accesses, after the initial one, are handled completely at the local disk without communicating with the file server at all.
Whenever there are two copies of the same information, such as our files on the file server and on individual workstations' local disks, you have the problem of making sure they're consistent. There are two different approaches you can take to this problem. One is to have the workstation, every time it uses a piece of data, check with the file server to make sure it is the most up-to-date version of that data. The other is to have the file server, every time a piece of data changes on the file server, to notify the interested workstations that indeed there's a new version of this data available for them. We've chosen the latter because it results in our environment, at least, in much less communication over the network.
In addition to transparently simulating a Unix file system, the Andrew file system can also be attached through intermediary machines to simpler microcomputers such as PCs and Macintoshes, so that they can view the Andrew file system as an extension of their own local file systems. Much of the work involved in producing the Andrew Toolkit has been directed at allowing users to produce documents which look good on the screen as well as on paper. This approach has enabled the developers to focus on the added dimensions afforded by viewing the document on the screen. Users of the system can create documents which not only have the look they want, but also have the behavior.
The original goal of the Andrew Toolkit was to develop a system to allow users to create text documents that include things like equations and tables and raster images and line drawings. We wanted to develop this system in such a way that the user could seamlessly use the objects in place without having to move from one editor to another. In building this system, we went further than building just a text processing system. We developed a general architecture that allows one sort of object to include another object. So, for example, just as our text object can include things like tables and line drawings and raster images, our table object can include text and line drawings and raster images itself. We did this in such a way that the system can be easily extended. We realized very early on in the project that we would not be able to build all sorts of objects, all the objects that can be used on the campus. The music department, for example, would want to have an editor that could edit musical scores. We wanted to be able to allow them to include that in as easily as somebody else could include equations, which is an object that we had built ourselves. One of the key features of the Toolkit is the separation of the information that is to be displayed on the screen and the actual image of that display. This separation allows us, for example, to have two windows on the same document, and where the user edits in one window, the change is reflected in both. This also allows us, for example, to have a table of contents on the document and the document itself in two separate windows. And when the user goes in and changes the heading in the table of contents, that change is reflected in both the table of contents and in the document itself. The separation between the actual information and its display also allows us to have two, what we refer to as views on the same information in the same document. For example, we can have a table which is represented both as a table of numbers visually on the screen and a pie chart. When the user goes in and changes the values in the table, the change is reflected both in the table itself and in the pie chart. The toolkit has been built using a simple C-based preprocessor developed at the ITC called Class. It provides an object-oriented environment with single-level inheritance while still allowing the programmer to develop what appears to be normal C code. One example of the use of this object-oriented system is our C-text object, which allows users to easily edit C programs. The C-text object inherits from its superclass, the text object, operations such as cutting and pasting and searching. However, it also provides functionality such as including comments and italics and automatic indentation that makes it much easier for the user to edit C code. One of the outgrowths of the design of the Android toolkit was the blurring of the separation between what are applications and what are objects. When somebody develops what appears to be an application, such as a music editor, that application is really developed as an object that can be used in more complex applications. This allows the toolkit to essentially grow as people develop more and more objects and provides the programmers with many, many more tools that would never be available in a much more closed system.
The initial release of the toolkit contains several useful objects, including raster images, formatted text, interactive tables, mathematical equations, hierarchical drawings, and simple animation. However, to think of these specific objects as the Andrew toolkit is to miss a key point. Because of its open architecture, it is now relatively easy to create new objects which take full advantage of the power of the toolkit. Given the appropriate hardware, for example, the toolkit can easily be extended to support real-time video, music, or voice. Because the toolkit dynamically loads the different objects as needed, new objects can be used as easily as objects which already exist within the system. And any toolkit application, such as the editor, the mail system, or the help system, has access to any new objects that are created. The Andrew toolkit and the Andrew file system have recently become IBM products. Both were announced in February 1988, along with the new 6152 workstation, which can support the Andrew system. The most highly developed end-user application in Andrew to date is the Andrew Message System. The Andrew Message System is a multimedia mail and bulletin board system with special support for reading messages from remote machines such as IBM PCs, Macintoshes, and time-sharing systems.
We started the Andrew Message System group around 2.5 years ago. We had three main goals in mind. One was reliability. And that really meant 100% reliability for us, because we felt that if during message delivery and reception the users didn't have complete reliability, that nothing else we did mattered and they wouldn't use the system. Secondly, we wanted an integrated system, and in particular this meant that we wanted any information that could be stored as a message to be treated the same way. The obvious things here are that mail and bulletin boards are in fact treated the same way. And lastly, we wanted to have support for workstations and environments other than just high-function workstations sitting talking to the Andrew file system. And so we really wanted to capture support for PCs and Macintoshes and possibly other systems that weren't exactly Andrew systems. Now the system itself is composed of essentially four main modules, if you will, that are actually very, very separable. And each of them is useful in its own right, although they're all packaged up here at CMU. There's the delivery system, the white pages, the message database, and a set of user interfaces. The delivery system is just what most people think it is. It's low-level, grubby, detailed code that's responsible for the final disposition of a message. The second component, the white pages, is a database and set of access routines that can be used to look up information about users. And in particular, it's useful for looking up addresses electronic mail addresses and converting them into information about a set of destinations. The message database is in some respects the most interesting part of the system. The message database is in fact the collection of all messages that exist in Andrew. Now these messages are in fact stored as a collection of files and related information spread throughout the Andrew file system. The nice thing about the Andrew file system is it gave us a giant storage medium, and it looks like a single file system essentially. So we get kind of all the advantages of a distributed database without the need for going into any of the contortions necessary to arrange for synchronization and updating and things like that. The access to the message database is done through a process called the message server. This is an integral part of our design. The message server itself has no user interface and is simply a process for accessing the message database. This is very nice for machines like PCs. It means that a user interface can run on the PC and make remote procedure calls over the network to a message server running on an Andrew workstation. So now the PC gets the full power of the Andrew message system, but doesn't need all the overhead. So, and in fact, this has led to a large number of interfaces for the Andrew message system with a wide variety of functionality. So there's a very low-level interface that assumes only teletype I/O and essentially runs on anything. It runs on Andrew, it runs on PCs, it runs on Macintoshes, it runs on VAX VMS. Up from that is a screen-oriented interface that is very popular now on PCs. And on top of that is our flagship interface, Messages, which is a full-blown window-oriented mouse finagling interface that uses the full power of the Andrew Toolkit. So in fact, we have multimedia mail on Andrew. The nice thing is that we obtain that essentially for free simply by using the Andrew Toolkit. So whatever power the Andrew Toolkit gives us, Messages obtains automatically. And in addition, we worried about how machines like PCs and Macintoshes would deal with multimedia mail. And we've come up with what I think is a pretty clever mechanism for allowing those machines to have that information stripped out and to simply present the kind of the text part of the message in a readable format with little indications that there was something neat here, but you can't see it because you're on a PC or a Macintosh.
With the help of several special features, Andrew users at Carnegie Mellon managed to cope with the flood of information produced by nearly 1,500 public bulletin boards, including all of Unix Net News and the Dow Jones Information Service. Andrew users can edit their own magazines, initiate bulletin board surveys, and receive automatic invitations to subscribe to new bulletin boards, as well as having access to many other interactive types of messages. To the user, Andrew appears primarily as a group of application programs on a Windows system. The applications use the Andrew Toolkit, which is Windows system independent, so that the user may be using the X Windows system from MIT or the original Andrew Windows system. The choice of tiled versus overlapping windows, for example, is a function of which Windows system is being used, not of the Andrew applications themselves. One of the first applications most users see is the Andrew Console program. Console is a system monitoring program that monitors such things as whether or not the user has mail, whether he has print requests pending, what the CPU load is, what files are being fetched or stored in the file system, and so on. It also monitors dozens of crucial functions of the underlying system and turns on a trouble light when any of them appear problematic. The console program is highly extensible. By writing programs in a simple language, users can create consoles that display very different kinds of information and present a very different appearance to the user. The other application program that users typically see when the system first starts is TypeScript. Basically, TypeScript is just a window onto the Unix C shell command interpreter, but with a few added benefits thrown in. For example, one can easily cut a sample command from a help window and paste it into a TypeScript to run it. The primary editor in the Andrew system is called EZ. EZ is not just a text editor, but is instead a generic object editor. EZ itself knows nothing about text, but knows how to load in the text object for editing purposes. EZ itself is equally capable of editing text, drawings, animations, raster images, or other kinds of objects. Some of these objects, notably the text and table objects, know how to embed objects of other types within themselves. Another key Andrew application is the HELP program. In the Andrew development effort, a great deal of work was put into the HELP system, but not at the level of flashy system features. Rather, a team of professional writers and rhetoricians was put to work to design online documentation that was straightforward and coherent. In the HELP program itself, help is available via several mechanisms. A portion of the help window lists the key overview topics about the Andrew system. Clicking on any of the topic names causes the appropriate help text to show up in the main part of the window. Users can select any word in the main help text and ask for help on that topic using a menu item, or they can simply type in a word about which they want help. In addition to these fundamental programs, a wide variety of additional applications have been built on Andrew over the last few years. Several of these applications have been built by the Carnegie Mellon and IBM staff members of the Information Technology Center, but a majority of them originated in other departments on campus. These applications have clearly demonstrated many aspects of the real and potential usefulness of the Andrew system.